Thank you very much. I'm just going to check the mic here. Can you all hear me? Everything's okay? All right. So I'm Anupam Pande. I'm one of the physicians at Washington University, and I stole this right out of Stephen Hawking's title, A Brief History of Time. But I am very passionate about infectious diseases, and I wanted to tell you why today and why it's one of the most exciting fields to be in and probably holds the key to the future of our existence. So I'm going to frame this talk to sort of give some perspective from history and talk about how humans and infections have evolved over time and how this will continue to do so in the future. So some of you in the audience might be very familiar with memes, some of you not so much, but we'll talk about a little bit as we go along. So what is infectious disease medicine really? What do I do? So when I don't know the answer to a question, I go to a friend called Wikipedia. Wikipedia tells me that infectious diseases is a medical specialty dealing with the diagnosis, control, and treatment of infections. That sounds really boring to me, but it's actually really fun because this guy here thinks that the definition of infectious disease medicine is the study between an interaction between humans and various critters, bugs, microorganisms, microbes, whatever you want to call it, that live in or on humans. That might gross some few people out, but there's a lot of things that live in or on humans. So these might be bacteria, viruses, parasites, fungi. You might have heard of some of these terms, but I study all of them. And why is that fun? Oops. So I'm talking bugs here. Not this guy. But these. So what's so great about learning about infectious diseases? It's the only branch of human medicine that really studies anything else other than humans. It studies all those things I talked about. But why is that important? Because there's lots of them. They're everywhere. And there's lots of them in you and on you. In fact, there's so many of them that 50% of the cells that are within this body are not human. So that might be alarming to some of you, but that's a lot. When I first learned that, I was like, oh, really? 50% of this is not me? That's just weird. So I thought about this some more, and I looked up some facts online. That's about 2 to 5 pounds of your body weight. So that's not a weight loss technique that I'm propounding, but if you were to kill every bug in your human body other than you, you'd lose 2 to 5 pounds of weight. It's not easy to do that, and we'll learn a little bit about why that is. So in essence, you are more microbe than you are human. So what else? What else do I like about this field? You know, you'll see a lot of cool doctors who fix the hearts. So there's cardiologists, and they like the heart. They mend broken hearts. There's the jocks of the medical world who fix broken bones. And then there's neurologists whose brains say that the brain is the most important organ we have. But I don't restrict myself to any particular organ because bacteria, viruses, fungi, they don't restrict themselves to any particular bacterial organ. They go everywhere. They go wherever they can make a way and find a place to exist. So I have to know about hearts, brains, bones, and so much more. So that's one of the things that keeps it interesting, it keeps it challenging, and makes me think, makes me want to know more, and requires me to know a lot about everything. Another thing that I really think is cool about what I do is that this is the oldest branch of medicine. People have known about infections since really, really ancient times. Yet, there's always something new going on. There's new superbugs, there's resistant bugs, they discover new viruses all the time, they identify new diseases, they figure out new treatments, and I have to be on my toes and be up to date with all of these things. So, I don't know if any of you guys are familiar with the song Chameleon Hair, but they see us evolving and they're hating. And this is just an example of how different bugs are just finding a way to be the next thing. So the history of humans, or many organisms, mammals in general, is intertwined very closely with the history of infections and germs. And both have influenced the evolution of the other. So there's very good examples in history about how bugs influenced how humans developed and how humans influenced how bugs developed. And we'll go into some of them in detail here. So what do you think this guy's doing here? Decomposing. He's decomposing, that's right. He's actually not been decomposing for 3,000 years. He's a mummy. He's been embalmed for 3,000 years. He's a very famous mummy. Not everybody could get mummified 3,000 years ago. You had to be very rich to be mummified. So this guy is Ramses V. He was an Egyptian pharaoh. And if you look closely, he's retained a lot of his features. Look at those cheekbones. But if you look closely at his skin, you can see that there are areas of the skin that look speckled. That's because he died of smallpox. Ramses V was very rich, but he couldn't avoid dying from smallpox. He was very young when he died. So even 3,000 years ago, we have evidence that there were infections. And there's a lot of evidence in more recent years that infections wreaked havoc. They created a lot of problems for the human race. You might have heard of Black Death or the Great Plague. It was a pandemic. Pandemic is incidentally a word that means a very large epidemic. I might want to remind the audience that my last name is Pande, which is the first five letters of the word. So there was a pandemic of plague in Europe. It started in Eastern Europe in the 1300s. And there were a few cycles of this pandemic. Every few hundred years, it would cause several million people to die. The largest one is called Black Death. It was in the 1300s. And it caused the extinction of half of Europe. It killed about, I think, 200 million people. And the population of the Earth couldn't recover until 200 years later back to its original numbers. It caused so much outrage, or not outrage, but like rioting and religious persecution even, because people thought that, oh, maybe these people who migrated from Central Europe or the Mediterranean Sea caused this disease. They were partly true. The disease was actually imported from the Mongols who invaded Eastern Europe. And then it resulted in scenes like this. This is Moscow in 1700s, where people are just fleeing and dying on the streets because of the plague. So this nearly wiped out half a continent. And throughout history, there are examples of bad infections causing trouble to the human race. Up here to the left is an ancient painting that depicts a gentleman with leprosy, which was for years considered a stigmatizing illness. This is a scene from World War I when the influenza pandemic hit the world and again wiped out generations of young men and women and children. It's influenced this game. It's a video game called Pandemic. If you are a nerdy and into such things, you should buy it. It's a lot of fun for the whole family. You can save an entire city from a deadly bug. So this all sounds really depressing, but there are a few things that humans did to outsmart these bugs. And I'm going to talk about just 5 people who changed the world and changed the way we do things today. The first person is this gentleman who's a Hungarian physician named Ignaz Semmelweis. He practiced medicine before the times of modern advances. There were no medications at the time, just things like potions and herbal medicines, things like that. This is in the 1700s. He observed, he was very shrewd, he thought that the rate of women delivering and then getting an infection after they deliver babies was very high in the doctor's ward, but not so much in the midwife's ward. And he was like, there's something women are doing right that the men are not. That's usually the case in history. But he was like, I'm going to figure out what it is. And and he figured out that the doctors performed autopsies on patients right after they did their deliveries. They delivered the babies in the ward. And he thought that there's something something that he's coming in contact with, something with the dead body that is causing these infections. He didn't know what it was. Nobody knew about germs then. There were no microscopes, nothing. And he did a comparison, and he clearly showed that if they were not to do autopsies, the infections went down. He further showed that if the doctors washed their hands, something that we consider basic now, if they washed their hands, women didn't get infections. That was revolutionizing for that time. In fact, the other physicians were so offended by Semmelweis that they had him persecuted. They basically proved that he was crazy. Semmelweis was imprisoned, and he died a very sad death because of infection in prison. After his death, though, he did get some recognition. Another man I'm going to talk about is Edward Jenner. This gentleman, he was also very shrewd. He noticed that milkmaids never get smallpox. So he thought about it. He was like, why is that? And he noticed that milkmaids get an infection from cows called cowpox. And once they get that, they never get smallpox. So he convinced this young 8-year-old guinea pig, poor guy, to get an injection of cowpox from this milkmaid. He scraped off some cowpox, he injected it in the kid, and the kid was exposed to somebody with smallpox but never got smallpox. And he said, voila, there's the first vaccine. Since then, there have been thousands of vaccines, and a handful of them are very, very, very effective. If Pharaoh Ramses knew about this, he'd be kicking himself. But since then, smallpox has been eradicated. And since the 1980s, nobody in the world has had smallpox. So that really changed the course of our generation. That and so many other vaccines like this one. All right, next guy I'm going to talk about is Joseph Lister. This guy, you might know this product here that's named after him. He basically said that if you clean things up with really strong alcohol, clean surgical instruments up with really strong alcohol, patients don't die after surgery. Similarly, this guy here, he got lucky. His name's Alexander Fleming. He was a British microbiologist and physician in the early 1900s. And you can see him working on his petri dishes here. He was working on some research on a bug called Staphylococcus that we call staph. And he left some plates in his drawer and went on vacation. When he came back, there was a mold on one of his plates. He noticed that this bed of bacteria underneath was not growing around the mold. He was like, what's that about? That's weird. He did some experiments and eventually figured out that it was because of penicillin. And since then, hundreds and thousands of antibiotics have been made in a similar fashion. Nowadays, they make synthetic antibiotics as well. But these have helped save lives for generations now. So that really revolutionized medicine as we know it. And we started ushering in the age of modern medicine. Which brings me to this guy. Infections have now been implicated in cancer as well. This is Barry Marshall. He's an Australian scientist. He was convinced that he's not just stressed out, there's something else going on with his peptic ulcers. And we knew till then, this is in the 1980s, we knew till then that this bug called Helicobacter lives in the stomach, but we never knew what it does there. Not many bugs can live in the stomach. Stomach has got a lot of acid in there, but this one somehow manages to survive there. And this bug you can't do experiments on. It doesn't infect animals, it only infects humans. You can't do mice models or animal models on this bug. So he said, I'm going to inject my own stomach with this bug. So he did a crazy self-experiment and he got a peptic ulcer. Eventually, his research proved that stomach cancer as well can be caused by this bacteria. He won a Nobel Prize in 2005 for all his work. It was not ethical for him to do research on any other human subjects, so he had to self-experiment. But it's people like him who've changed the landscape of infection. So how does this really impact what I do every day? So I can classify my job into 5 distinct sections. The part that I like the most is I treat patients. I talk to patients every day. I teach students, medical students, doctors, future doctors. I do some research. More than that, we have a responsibility of preventing infection in the community, in the hospital, in the world at large, and preventing antimicrobial resistance, because that could be the next thing that wipes out a generation of humans. So I'm just going to break these down a little bit and see how those scientists that we talked about influence my daily practice. So I talk to patients every day. It's one of the joys of my life because I get nosy and ask them questions that nobody else does. I ask them, is your dog friendly? Does he lick you? Does he bite you? Does he scratch you? Is he clawed? Is he declawed? I ask them, do you have a farm? Do you have hobbies? And these are the things that give me clues that, oh, this is maybe that kind of infection because he has a certain exposure. So I get nosy. And then, thanks to Alexander Fleming and thousands of scientists like him, I have at my disposal a wide array of antibiotics today that I can use. It is my responsibility to use them well, Otherwise, there can be problems. Oops. Oh, what happened here? So part of my job is to work on infection prevention in the hospital. So we don't wrap everyone in plastic gowns like this, but hand washing, hygiene, wearing the right protective equipment when needed is a big part of my job, making sure that patients are isolated correctly when they need to be, and they're surveilled when they need to be. So that's a second key component of my job. Preventing infection in the community is important. I like this picture of him dabbing while he's trying to sneeze so that he doesn't spread germs. But I wanted to share a fun story, well, not really that fun, but there's this lady who was a cook in New York several years ago who was the source of several people, mainly her customers, getting typhoid, and she was labeled Typhoid Mary. So it's very unfortunate. She again didn't have a very good fate in the end. She was imprisoned because there was no treatment for typhoid at that time. But in today's day and age, if we know that someone's infectious, we can isolate them, we can treat them, and just by treating them, we prevent a large part of the community not getting that infection. So that's a big part of my responsibility. We prevent infections in the world. Humans are travelers. We are not nomads anymore, but we're still travelers. So there's a new infection every time that you hear about. Every 1 or 2 years, we hear about something. 2 years ago, it was Zika. It was a new virus that hit the Caribbean and South America. And everybody who had been there was worried about Zika. So every time there's a new scare like that, we get involved and make sure that travelers from there who are coming here are safe, because germs are everywhere. And then I do some research. So just like those 5 gentlemen I spoke to you about who did research, maybe not on that level, I don't self-experiment, but I do have a set of patients that I study some research questions in. My interest is in patients who have received stem cell transplant for their cancer, for leukemia or lymphoma. They tend to get a lot of serious infections, and my focus is on trying to prevent them. But I think it's important these 3 aspects are important to develop that research outlook. You have to be curious about why certain people get certain diseases and why certain people don't, and you have to be observant. You need to experiment. And then you need to have what I call serendipity, which is sometimes you just need a stroke of luck, like Alexander Fleming. You need fungus to grow in your plates that gives you the key to penicillin. And then my last responsibility is to prevent antimicrobial resistance in the world. And how do I do that? By treating people appropriately. When bacteria don't get enough antibiotic exposure, they don't die. And what doesn't kill you does make you stronger. Kelly Clarkson is right. So that's how you get superbugs. You might have heard of MRSA or MRSA. That is, we're going back to the same staphylococcus that Fleming was working on. That is methicillin-resistant Staphylococcus aureus. It's one of the most prevalent infections in today's day and age. It doesn't respond well to some old-timer antibiotics, but we have some good antibiotics against it. When Alexander Fleming was working on Staphylococcus aureus, good old penicillin killed it. Today, not even one would die. Several classes of antibiotics don't work against it. In the future, maybe what we're using today won't. It could be the next superbug. There's also so many more. I could kill you all with abbreviations, but there's CRE, KPC, ESBL, there's like tons of them that as we speak are becoming more and more prevalent in the community. And people like you and me are getting these infections. You don't have to be terribly sick to get these infections. So we have to be very careful about prescribing antibiotics. When they're not needed, and they should not be used. And you need a good doctor to make that determination. So I like this cartoon of father staph and mother staph telling baby staph to stay away from drugs, because that's how we become stronger and becomes the next superbug. And the last thing I do at the university is teach students. That's another joy of my life. I love teaching students. I love talking to people. It's something that keeps me sharp. It keeps me young because most of my students are younger than me. And it's also a fun way to learn. Kids can be the best teachers. So with that, I want to thank some of my friends who helped make this talk possible. These would be microbiologists in the lab that work with me. So these are the people who help me with diagnosis. They help me figure out what's growing in the cultures from my patients. There's pharmacists who help me out with different medications that I want to try on my patients. My nurses, my social workers. There's so many more that are in the team that help make good health a possibility for my patients. So I want to thank all of them. And the noises that you've been hearing in the audience are my son. So I want to thank my son and my wife who are here. Don't worry, it'll be bedtime soon. And with that, it's question time. I'll take any questions that you guys have. Thank you very much for having me here today. Yes?
How often do you get sick?
How often do I get sick? I didn't get sick for quite a long time until my son started going to daycare. So we're really good about infection control in the hospital. So every time we have a suspicion that a patient could be contagious, we take the right precautions. We wear masks, we wear gowns, gloves, if we have to. I see a lot of patients with flu, respiratory viral infections, gastrointestinal infections. We've had scares with measles or infections that can be prevented by routine vaccines lately. But we're very aware of what needs to be done. A key aspect of my team is my infection prevention nurses. They're always talking to the State Department of Health epidemiology lab. That's where all the latest numbers for what's going on in Missouri, what's going on in particular county are up to date. So they tell us what to watch out for. They tell us that there's an outbreak of cholera going on in a certain part of the country, and then we know about it, and we can prevent it if we know one person's coming from that area, or he lives there, or she lives there. So I don't get sick that often. Yes, young man.
Is it true that if smallpox came back, there wouldn't be enough vaccinations to help?
That is a concern.
Can you repeat her question?
Sorry. His question is that if smallpox were to come back, there may not be enough vaccine to prevent it. So that's actually a very intelligent question. There's two parts to it. One is that right now smallpox is something that's considered a bioterrorism agent. It's very safely contained in the hands of a few labs across the world. So not everybody has access to it. But if somebody had nefarious intentions and they somehow managed to get access to it and spread it around the world, there is a possibility that people could get infections from it. The vaccine itself does not treat the infection. So it's a matter of high national or international security that those strains are kept contained. If it were to break out, the Center for Disease Control and the World Health Organization has a very detailed plan, and I don't know all the details of it, but a very detailed plan of how it must be dealt with and how that infection could be contained. Yes, follow-up question?
Are you well aware that the smallpox could change its genetics, like other cells can? It can infect people, and you could try using the old vaccine, and that might not work.
It's possible. Again, all of these are theories that are very possible, but these are things that are so low on the likelihood of things happening that there's a specific group of scientists working on it. I'm sure they have a very good plan if things were to go wrong. So I wouldn't want you to worry about it. Right.
Where are we on the common cold?
Say that again?
Where are we on the common cold?
On the common cold, unfortunately, the common cold is very tricky. So the virus that causes it cannot be eradicated, is my opinion. It just mutates and changes too frequently for a vaccine to work against it, and there are no medications that work against it. So we've managed a lot of victories in the last centuries, but we have not made any progress on the common cold, unfortunately. My view is that we need the common cold. It helps in getting people to stay at home and not travel as much, and it helps people from not getting too close to each other sometimes. So I think we need things like that to control society in a way. Yes, young lady there. There are a lot of interesting memes out there. A lot of them have to do with infections, but I'm sorry, the answer is probably no. Yes, go ahead.
Are you doing any work on mitigating the current outbreak of chronic wasting disease in the earth?
No, I am not. I'm sorry. I work only in human medicine. Yes.
You mentioned about interaction between humans and bacteria. What about colon flora? And implicated for maybe causing depression and eating weight gain and things like that.
So that's the latest buzzword in my field is microbiome. A microbiome means the bacteria that live in different parts of our body. So the colon flora is called the gut microbiome. It's very tricky to study it because there's literally thousands of bacteria that interact with each other and not just with the human body. And there have been a lot of things linked to it. So it's been proposed that a certain kind of microbiome helps with weight loss, inflammatory bowel disease, certain infections, certain autoimmune conditions or things like lupus, rheumatoid arthritis. There's a lot of research going on about that, even at my center. I'm not a part of that lab, but I can tell you there's so many things happening. They're figuring out how the microbiome becomes resistant, how it helps shape how people think, how people do things, how people survive, that they might figure out that the next pill for depression is somebody else's microbiome. It might just be, right? Yes, young man.
Could you, for the common cold, couldn't you just do something that could change the immune system so that way the body would be naturally immune to the common cold?
So that's how vaccines would work. So there's permanently boost the immune system. Sure. So there's a lot of things that have been tried, or natural remedies that do boost the immune system. A good example. A good example is vitamin C. There's some controversial studies and research that shows that if you take a large dose of vitamin C just before or in the beginning stages of a common cold. It boosts your immune system, and your infection is not as bad as it would have been without the vitamin C. So there's research like that that's happening all the time. Unfortunately, they haven't till date shown a consistent effect. So yeah, I think we're not going to win that battle. All right, any other questions? Yes.
So I'm just curious about the influenza vaccine.
Mm-hmm.
You know, there's a lot of people get it, a lot of people don't. It's
Yep.
effective, it's not effective. They guess wrong this year. It worked, it didn't work, it worked partially. And so I'm wondering where they are in creating, you know, like.
So I'm glad you asked that question because it's one of my soapboxes that I talk to patients about all the time. So the influenza vaccine is made freshly every year. It's something that requires a lot of preparation. Every year, they, based on the strains that were in the community the last year, they try to predict what would be the scene like in this upcoming fall and winter. So about summer, they start off researching, and it's a very long and laborious process for them to come up with the combination of strains that they need to use and an effective vaccine that's ready by fall. So it's a very tight calendar. And based on that, every year the vaccine is different. So every year the vaccine works differently. We cannot predict with 100% certainty that this is what's going to happen this flu season. So sometimes the vaccine works very well, sometimes not so much. This year it seems to have worked a little bit better than last year. So last year there were a lot more patients getting flu a lot earlier on in the season. This year the peak seems to have been shifted towards right now, right? We were just seeing the peak of influenza in mid-January. So because of that uncertainty, it's hard for doctors to know for sure whether it works or not. What we do know is that if you do take the flu vaccine, the likelihood that you'll get serious life-threatening influenza is much lower. Is it 100% effective? No, it's not. Every year it's different, but we don't know that till the end of the season. We can only calculate the numbers based on how many people get the flu in that season, but by then it's too late. So what I would say to you is take your flu vaccine. It may not work 100%, but it will prevent you from getting the worst kind of flu.
Right, but aren't they working on more of a vaccine that is like a permanent vaccine with like not all the strains or the past all the strains and the predicted strains, but that is supposed to work more permanently?
They are working on it. I don't know if that will be available for this next year's season or the season after that, but vaccine trials are a very long and laborious process. They take years, decades to come up with the final product that really works. But until then, we're stuck with what we have, which is pretty darn good. It's not, it's better than not doing it. Yes?
Can you talk about a bug called C. diff?
Sure.
In some instances, it's very dangerous, especially older people, when they're like, not well at all.
So we're coming back to the microbiome there. C. diff is something, it's a bacteria that lives in your intestine. And it's supposed to be there. It's one of the good bacteria. Unless that's all that's there. And it starts making a toxin. What happens usually is that people get antibiotics for something else. Sometimes they need it, sometimes they don't. And it kills off everything else, but not C. diff. C. diff actually stands for Clostridium difficile. Difficile is the French word for difficult. It's very difficult to grow in the lab, and a lot of antibiotics don't work against it. A lot of regular antibiotics don't work against it. If you are unlucky enough that your C. diff starts overpowering all the other bacteria in your gut and multiplies at a large rate and starts making toxin, you could get a serious infection called colitis, or causes diarrhea, inflammation of the colon. And that varies from being very mild and sometimes hardly noticeable to a very fulminant infection which can kill off your colon and could kill you. It tends to be worse in people who are older, especially once you get above 75. And it tends to cause sepsis, or you might have heard of sepsis or septic shock, which basically is a derangement of all your organ functions, which could which could end you up in the ICU, and people die from this on a daily basis. So that's one of the big reasons we are very careful about using antibiotics, because a lot of them cure things, but they could cause unwanted consequences like Clostridium difficile. Yes, sir.
Do you have an opinion about the trend of parents refusing vaccines for measles, mumps, whatnot?
Well, I do have an opinion. I very strongly recommend vaccination to all my patients because I know the power of vaccines and I have the knowledge behind all of those years of medicine learning about vaccines and what's happened. I come from a country where people still die a lot more from infections. I'm from India. So I've seen people get measles, I've seen people get rabies, I've seen people get polio, and I feel very strongly about people accepting vaccines and using them appropriately. Yes?
What would happen if there's another Spanish flu outbreak?
What would happen? I don't know. So the Spanish flu is what we call H1N1. It's the name for the flu that has been around for the last 10 years or so as well. It disappeared for a long time and then came back. And the vaccine right now would prevent it if it were to happen, or at least mitigate the effects or make it not so bad if it were to happen. But if it does happen, it could be similar to what happened in 1918. Yes.
I have a question.
Oh, there is a medicine for influenza that works if you do it early enough. So you could treat. Sorry, I didn't mean to cut you. You could treat it if you know that it is the flu, if you know about it early enough. So hopefully things won't be as bad if it were to happen. Yes.
I'm a person who has artificial joints, like an artificial knee and an artificial hip, and my orthopedic surgeon is adamant that I take antibiotics before I go to the dentist. But I have other friends that their surgeons say no need to do that.
So that's one of those controversial issues where some doctors think one way and some doctors think the other way. The science used to be fairly split on that. Of late, the evidence has been, or more doctors have been against supporting antibiotics for that because there hasn't been shown a significant risk with dental procedures and other things like that. And we've become wiser to the harms of antibiotics in recent times. Somebody mentioned C. diff. There's a lot of other problems. Drug resistance is a problem. So we don't want to use antibiotics when they're not absolutely needed. So if you ask somebody who does infectious disease medicine, they'd probably tell you not to use antibiotics for a dental procedure for a prosthetic joint, even if you have had an infection of that prosthetic joint. Yes, sir.
Do you have any opinion about probiotics that they've been pushing on everybody? Are they effective, especially in the cancer area?
So, good question. So probiotics is a big industry and it's not FDA regulated. What that means is that every probiotic you get out there is different. Some products have a certain bacteria, some products have another one, some have a combination, and they're not regulated, so nobody knows exactly how much is in each. Having said that, probiotics are shown not to harm in certain patient populations. So as long as you know that your gut health is reasonably good, your bacteria won't cross over from inside your gut into the rest of you. Now, that's a determination that's not easy for you to make. It's something that your doctor should make. and should let you know whether probiotics could harm you. In most people, they wouldn't. Most things that are fermented that we eat contain things similar to probiotics. So yogurt, sauerkraut, beer, all of them contain bacteria. And these are bacteria that are similar to what's in probiotics. Having said that, I've seen patients get infections a few weeks, months after having taken probiotics if they had, say, cancer and were getting chemotherapy, or they had a transplant of their liver or kidney or stem cells or something like that. So in the right context, they may be beneficial. They might help get those good bacteria back in your system if your microbiome isn't healthy. Because it's such a dysregulated product, it's not been able to be studied with scientific rigor. So we don't know for sure whether a certain probiotic is the same as another probiotic and whether it's just as good or just as bad. So it's got to be a question that's difficult to answer unless the FDA one day says, that's it, all the probiotics need an FDA license. And that's not going to happen because it's an over-the-counter product. So again, the science is divided on that. It may be good, but only in certain patients would use it with caution. Yes, sir.
Yeah, every few years it seems like there's a new infectious agent developing. What's the mechanism for new infections like SARS or MERS?
Yeah, so that's probably been the case for millions of years. We just are now getting wise to it, and we're being aware of it. But it really depends. So, for example, there was an outbreak called MERS in, it stands for Middle Eastern Respiratory Syndrome. It was a new virus that started somewhere in Saudi Arabia, and then because people fly all over the world, it went to Europe a little bit, and there was a scare about it. That one, they said, maybe comes from camels. We don't know. SARS, they thought came from, it came from pigs and birds and things. There was swine flu before that came from pigs as well. So usually the way this happens is the virus that's been in the system somehow changes that it can now attack humans. Maybe it couldn't attack humans, or it was secluded from humans for some reason. And now suddenly it's developed a new mechanism to be able to infect humans. It's really something that changes in its DNA. And that's how it happens. But there might be other mechanisms that we're not aware of yet that might lead to such changes. Yes, sir.
One more question about Ebola. How come you hear about it a lot over in the African area, but you don't hear about a lot of it in the North American area?
That's thanks to the Center for Disease Control. They did an excellent job of containing Ebola to a few countries in Western Africa. So it was contained to Sierra Leone and Liberia and maybe one other country. But they ensured that every time anyone travels to those countries and comes out to a country that doesn't have Ebola, there were very strict questionnaires that people had to answer. They had to undergo quarantine. They had to make sure that those people were not infected. Scientists from CDC Atlanta who visited those countries for research, for medical care, had to undergo very strict precautions when they came back. I spoke to a scientist in one of our conferences, one of our annual infectious disease conferences, who had returned from such a mission, and they figured out that he had the virus in him for several days, so he had to be quarantined for a long time. He told the story. It was a beautiful story. He's written a book. You should read it. I forgot the name of the book, but you should read it, about chronicling how they dealt with the outbreak there and how they managed to contain it. Fortunately, right now, Ebola is not a concern even in those countries, and because of those excellent efforts that they undertook at the time, most Americans didn't have to worry about it. I forgot. I spoke. I forgot. So I should put my contact information or email address on there. But if you have any more questions or follow-up stuff, or if you need an infectious disease consultation, or you need to come to Barnes for some reason and you need assistance related to infectious diseases, I could put my email address out there for you guys to get in touch with me. And if you're considering a career in infectious diseases, it's never too early to start. There's always people who are doing cool things in the laboratory or in the hospital or in different places in the community. And you could always find a way that your skills, talents would help them. I'm sure they would appreciate it, and I'm sure you'd get a kick out of it, learn something exciting, and hopefully it will convince you to pursue this awesome field.
Thank you.
Thank you very much.